Namaskar, my dear friends. So, in the past session, we have seen what is ADC, how to calculate ADC values, and what are the different applications that we can have for ADC pin circuits, right? What are the things that we should take care of before designing ADC, like circuits. So, what we'll do in this session is we'll try to see various application circuits so that you can have a practical knowledge or practical understanding of directly connecting your circuits to ADC pins, right? So in the last session, we had seen we had started with this particular circuit. Let us say we have some voltage to be monitored by ADC, and this is how we had connected to a voltage division, then send it to your buffer, then filters, and then ADC. So this is my buffer, and this is my filter, and this is the ADC pin of your microcontroller, or either it can be sent to an external ADC also. However, we had used recently a PIC 16F46 Q71 for various automotive applications and all. That's the reason we have used this circuit for your understanding. So let us say next circuit that we can see is voltage monitoring for, let us say we have to have 3.3 volt and 5 volt. So what we can do is we can same way design, let us say let us say we have one circuit 3.3 volt. So this is the voltage division that is going to come, and let us say this is my Vx voltage that is going to appear, which is lesser than the V reference that we have decided, let us say 3.3 volt. Then after buffer, then send it to an filter, and after that it will go to your ADC pin of your microcontroller, okay, or an external ADC, anything is fine, okay. Similar to that, same thing will happen with 5 volt as well. So you can see the resistance is varying, and here resistance is varying. It all depends on you, like how much voltage you want to have at this particular node. That must be less than V reference, that must be understanding. Let's say Vx must be less than V reference that you are going to utilize from your circuit, okay. Another application can be a potentiometer. Basically what you do is you vary your potentiometer. Let us say this is the potentiometer that is connected. So one of the pin is connected to VDD power supply. Another one will be connected to my ground, and one will be connected to the varying resistance. So as you rotate, the resistance up and down will vary, and this is how you will be having a voltage division here. So that voltage division will appear, and this will go to my ADC pin of my microcontroller, which is going to MCU ADC pin. Okay, and this is how you will be able to see a difference at the ADC value measurement. All right. So this resistance of potentiometer actually gets converted into two resistance part, let us say R1 and R2, and this is how you're going to have a voltage division at this particular place. Okay. Another application that you can see is, let us say, ambient light sensor. So I had used recently one application circuit for ambient light sensor, that is VEMD 4110X01. That is from Vijay. Okay, so Vijay Semiconductor is one of the best company for sensors technology. So here it has been used, and this is an integrator circuit with amplification, and then it is going to a amplifier, and after that it is going to a filter. So then again this ambient sense will go to your ADC pin. So this is how you have various applications that you can connect for an ADC pin by designing a proper circuitry before sending it to your ADC pin. Okay. Let us say another circuit. This is very widely used for temperature sensor measurements. So there are a lot of ICs like this which is having a very better capability to give you a linear variation of voltage based on the temperature. So this is my temperature, and this is my voltage output. So let us say for each 1 degree centigrade, there will be a 10 millivolt of voltage variation. Like that, this particular IC shows a characteristics. So what happens is, as the temperature increases, the voltage will increase at this V output, and this is going to go to my ADC pin of the microcontroller or ADC converter. Anything is fine. Understood? So this is one more application circuit. Let us say one more application circuit for analog temperature sensors can be with LM35, which is most popular, IC for temperature measurement. for various applications, let us say thermometers and all other temperature measurement on the board. So let us say we have 5-volt input for this particular, like a power supply of temperature sensors, and the output will go to your ADC pin. So hope you are now able to understand and realize the importance of ADC pin, that is having a versatile application of various locations in your circuit. All right. Let me give you an example for pressure sensors. So pressure sensors, what happens is, let us say we have a pressure sensors. For example, I have kept it for 30 psi application. So this 30 psi pressure sensor is from, I think it is from Honeywell. Okay. So this power supply and circuit design, this output is going to give you a single ended output, and this single ended output, not only it is acting as a buffer, but it is acting as amplification as well. You can see we have, like 56 plus 1, so this is going to be 57 times amplified, and then low pass filter, and after that it's going to be your pressure measurement to your ADC pin of my microcontroller. Okay, so this is how pressure sensor circuit also can be designed to measure the application of what is the pressure level at this particular, pressure sensors. Another application of pressure sensors, you can see this one. So this is the pressure sensor that is again there from Honeywell. We had used for, plus minus output, that is kind of the differential outputs. So this differential output is going to go ahead with two op amps. One is here and one more is here, right? And then it is going to go ahead and give you the pressure sensor output. So this pressure sensor output is going to go to my ADC pin. Okay. As you can see, this negative input has been voltage shifted or something like that, and then this again connected to this one, P1. You can see this is connected to P1 like this. Okay, so this is how you're going to go to your ADC pin of microcontroller to measure what is the pressure level of this particular IC that has been measured. Okay, so this is again pressure sensor output, pressure sensor application, right? Okay, let me give you one more example of NTC, that is negative temperature coefficient. So these are basically used for a study application on, like temperature sensor measurement. So what happens is, temperature sensors will be attached to this particular connector, and based on the temperature of the sensor, the voltage at this particular node will vary, because the resistance at this particular two pins will be varying, right? And that is again going to an amplifier or filter, a buffer, and then filter, and then it is going to go to your ADC pin. So as you can see, I have given an, option for having an amplification as well. So if this is not enough amount or not enough voltage level, then we can go ahead with amplification process as well. Otherwise, you directly connect it to, negative input to the output, so that it acts as a buffer. So right now this is acting as a buffer because this is not used, and this is 0 ohm. So it is directly connected to this. So it is acting as a buffer and then filter. So hope you have a good understanding of NTC as well. So there are various understanding of MCU. Basically, we have MCU ADCs or, like FPGA ADCs. So your aim is to connect all the ADCs that we just now studied, the application circuits, to these pins of your, like FPGAs or microcontrollers, and those ADCs will be acting as a measurement device to give you the count, so that you can understand what is the voltage level of the sensors that is connected. Another way to connect those outputs is to connect to an external ADC converter. So this will be having an input pin which will be connecting, to those voltage measurement circuits or all those sensor circuits. And the data that is converted to ADC, so this ADC data will be sent to either, let's say, I2C interface or SPI interface or various other interface technique is there, microbus interface technique is there. So that can go directly to your microcontroller or FPGA, and this is how you will be able to find out your ADC value and store it here. So MCU or FPGA will not be involved to convert ADC value. Actually, external ADC will be used for that purpose. Let me give you an example for that. Let us say one simple, like microcontroller system that we have designed. So you can see we have ADC input here, Then we have ADC input here also. Okay, so you can change the names. Okay, then we have like temperature ADC3 here. So there are a lot of ADCs that has been used in this particular microcontroller that you can see. We have ADC in here as well. Okay, so this is how ADC is utilized. If you talk about a ADC circuit inside, like an external ADC, if you talk, let us say I have ADC IC. Okay, so this ADC IC internal circuit, you can see we have the ADC input here. So this is differential input that is coming up. Then we have clamp diode, which is going to like use for protection purpose. Then we have span compression or like driver circuit, and this is having ADC circuit, which is going to be 16-bit ADC. So one of the IC that we had used is AD4008. Okay, for the application of ADC converters, and this is having SPI interface. So SPI interface, you can connect it to your FPGA that is there, or even MCU that is there. Okay. Now let me give you an example, like how I have just given you the circuit how to connect to ADC pin. So either you can take an example of input voltage, connect it to ADC pin through a filter circuit. That is one thing. Next one is connect your input voltage to the buffer and then filter circuit, then ADC pin. Okay, so keep these processes in mind. Okay, to connect to your ADC pins. Another way will be connected to this is again input voltage that is going to connect it to my ADC pin here. So this is my filter, and this is amplifier as well as like integrator. So what is happening is one step of filtering is happening here as well as one more step is happening here as well. So what happens is there are two steps of like filtering. That is, first step will be little longer. So this is my FC1. Another step, next stage is going to have is like this FC2. So instead of directly coming to this particular level of like filtering, we can have little bit longer range and then come to lower range. So this is how a two step of filtering is preferred in some applications. Another way of application for ADC filtering and amplification is like band pass filter with amplifier. Okay, so band pass filter basically used in your like ECG application or blood pressure monitor applications. So in ECGs and blood pressure monitor, let us say you can see 0.3 hertz to 4.8 hertz. This is the band pass. So this band pass is basically working something like this. Okay, so this is my zero point 0.3 hertz and this is 4.8 hertz application. So this will actually like save your input signal from external noises and all. So this is first level of or first stage of filtering. Then another stage is this one, band pass filter. One is 0.3 hertz using this one or this one, and 4.8 hertz using one of these. Okay, then connect it to your ADC pin. So why don't we see like what are the various parts that we can use generally, so I can give you an understanding of some part numbers. So let us say some TI part number I have listed out which we have used in various applications recently. Okay, so like ADS 8860 or ADS 8864, 88 ADS 8865, like that you can utilize. Similar to that, we have analog devices part as well. So let us say we have AD 4008 or 4004 or 4000. Okay, so if you want to go for higher speeds, you can go ahead with these ones as well. Okay, and higher accuracies. Similar to that, we have Max IC from Maxim Integrated, and linear technology ICs are also there, which is used various applications for ADCs. Okay. So what is the best way to find out the ADC part number is any of the data sheet of your analog devices. You go analog devices, what they do is in their datasheet itself they give a table of like what is the number of bits, let us say 14 bits, 16 bits, 16 bits, 18 bit or 20 bit and all these things, right? Then what is the speed, like 100 kbps, 250 kbps or 500 kbps or 1000 kbps, right? In that case you can see we have, let us say 14 14 bit 100 kbps is AD7940. So using this table, you can find out your required ADC that you need. Let us say we need to have 16-bit ADC. So for 16-bit ADC, we can go ahead with this IC AD7684. Similar to that, if you want to go ahead with little bit higher speed, let's say 500 kbps, then you can go ahead with AD7688. Understood? So this is how this table can be very useful to you. The same table can be found out from any ADC, like data sheet, and they will be having listing of different ADCs. All right. So all right, guys, this was all about like application circuit that we connect to the ADC. In next session, we'll try to understand delta sigma ADC as well. So if you do have any question regarding the ADC application circuit design, or like how to connect to the ADC pin for monitoring a voltage labels or something like that, you can always put down your request or reach out to us for your specific requirements. Thank you.